All right, my friends. So there was a quiz Friday. We're going to start a review. Let me grab this real quick. And let's put phones away, please. You can either put them in the pouch if you can't handle it, or you can hide them completely. So this review that we're going to be doing for the next, quite a few days, I would hang on to these sheets. These are not in your book, though there might be some review in the book. So keep bringing these sheets back and forth. Someone here? No. Oh, okay. No, you're perfect. Yep.
Thank you.
Giddy up. All right, so I got to teach off this board. I'll be recording off this device, so if you watch the videos, you actually see me in the video. Yay. Man behind the screen. All right, so we started this semester with reviewing or going over adding polynomials, different things that go with it. So this could take a couple days. You write down what you need to. If you would like, you can grab one of these sheets of paper if you wanted to try it on, and then on this actual physical thing, you write the right answer. So will you try problem number 1? See how you do. See if you remember it. If you don't want to write this on your sheet that you currently have, you can grab a sheet of paper and put it on that, and then double check your work, and the correct version you can put on this. So go ahead and try that problem. See what you can do. If you feel you're getting stuck, I'll bring this around if you want. Anyone want sheet paper? Sheet of paper, sheet. Yeah. Yeah, if you wanted to try the problem on this and then you make the correction on there, you can. I give you 2 just in case. Anyone else want some paper? If you do, it's up here. Oh, you'd be lucky if you found one of those. Yep. All right, so let's talk. You had the opportunity to try it. So we're taking a look at this problem. What do you think? Can I drop the parentheses as it sits? Or do I need to distribute anything over the parentheses? What do you think? Well, is there anything sitting out in front here that I distribute? If I distribute this positive, does that change anything? Nope, so I can just drop the parentheses. And of course, I'm writing the whole thing out. Okay? So if we did that, that works. Notice that positive, I distributed the positive over, it didn't change any of the signs. But if I distributed over a negative, that would change all the signs, agreed? We're just working on this as part of starting our review. All right, so now we feel good. What can I combine together? What makes a like term? What makes an unlike term? 5 and 12. So 5 and 12? Okay, we'll start there. That's a good one to put together. What else can be put together?
Negative x to the 4th.
Yeah, good. So that and this can be put together because those are like terms. And then anything else can be put together?
Negative 10x and negative 7x.
Yeah. And so I like good thought process on that. So a like term, if you remember, has to be the same letter, which is a variable. That variable has to have the same exponent it's raised to be a like term when we're adding or subtracting. Okay, so let's go ahead and do our math. So if I put this and this together, there's a 1 right there, right? So what do I get?
7x to the 4th.
7x to the 4th, good. If I put those together, what do I get? There you go. Got it. If I do the blues, what do I get together?
Negative 7.
Okay, I'll put a negative 7 down here. And if I put the greens together, what do I get?
Negative 17x.
There you go. So that's our entire answer, okay? So let's go down to number 3. So I'll hit the odds. But do you feel comfortable with what we have up there? And I'm just I'll move this out of the way, but if we have to come back to something, we can find it someplace, okay? So I'll just move that. All right, so number 3, realize number 3 is right below number 1. All right, so the difference between the first one and this one is this is a subtraction problem. So what happens to everything here? The signs flip, right? So if I distribute that negative over, this comes here, here, and here. This one stays as is. I want you to notice, and I'm doing this on purpose, this, and this are different signs than when it was grouped together. Agree? Okay, so we distributed that. So now we can start combining our like terms. So again, we have a like term here, a like term here. We have a like term here and here. And we have this last like term here and here. So let's combine. So 17x squared minus 4x squared is 13x squared. 2x and 4x is 6x plus 5. Done. So when adding them together, just drop the parentheses, combine like terms. Make sure you're watching your signs. When it's subtracting two of them, then we are going to make sure we distribute the negative over, changing all the signs to the whatever's to the right in the parentheses. Pretty straightforward? You feel comfortable with that? All right, let's move this up. Can I move it? Let's see, can we find our original? Oh, good, our original's still there. All right. Number 5. Again, we're going down that left column. Okay, so we get this. So what are some things we should do with this? What do you think? Distribute the 8x squared, right? Remember, when we're distributing over the parentheses, when we are multiplying, what do we do to the exponents? We add them, good. So this whole value here is going to get distributed here, here, and here. Watch your signs. So 8 times 1 is 8. X squared times x to the 3rd is x to the 5th. And then 8 times 2 is, make sure you put the plus sign in there, 16. X squared times x squared is x to the 4th. Just add them up, right? And then 8 times negative 6 is negative 42, isn't it? It's 42.
I think it's wait, 48.
48.
Yes.
Ooh, boy. Syrup slept or something. Thank you. Negative 48. X squared times x. Well, you have to realize that's to the first, so it's x to the third. Are any of these like terms to combine together?
No.
Yes or no? So look at the exponents. Are all the exponents, any of them the same, or are they all different?
All different.
All different. So that's your answer. You can't go any further. Okay. So let's pause for a minute. Some of you are singers and or musicians, but I'd say all of us like to listen to some sort of music. Agree? So when you listen to music, you can definitely hear if somebody is singing the right notes or playing the right notes or keeping the correct beat on the drums or the bass. Okay, now if you play piano, you play both parts of the music. If you play the drums, you're keeping the beat, you're keeping the tempo. If you're playing the bass, unless you're on a solo, you're also keeping the beat. If you're playing guitar, and I'm just thinking of just a band that doesn't necessarily have horns and orchestra and stuff like that, but you can tell when something sounds good and something that doesn't sound good. So if you were to graph something like this, okay, that's raised to the 5th power. 5th power when graphed looks like that. Okay? A sound wave also looks like this. It keeps going forever. Okay? It looks the same. Now, I'm not too concerned about where these are crossing the x-axis, the max or mins, anything like that. That's just, in tradition, what they would sound like. So if you were to take 2 different musical notes, and let's say this is a C note looks like this when graphed, and a D note might look like this. Okay, so they look kind of the same, but they're off just a little bit. If I were to add these together, you're going to, wherever you have peaks and valleys, take place. So if we put this on an x-axis, an xy axis, if you had one note that did this, if this is what one note looked like, and this is a different note, okay? Things that are taking place with this is each little part. So when I get to right here and to right here, we would add that. There's a certain distance, which is going to get me up here. If I get to right here, if I added those 2 parts together, being they're about the same, we're going to get to here. If I get to this max and this min looks a little bit more, so it might be about here. If I get to this region right here, bless you, it's going to be here. If I look at this max and this min, this one looks like it's slightly above. If I got to here, that would probably be a 0. So the music note that we would actually play might look something like this. Okay? So that, it's the combination of the two. If you play a C chord on the piano, it's 3 keys. Push them together. and it sounds good. If you change your thumb from being on C to your thumb being on B, but you play the other two, it's going to sound a little bit different with the chord together because you're hearing the summation of the music to get there. Now, I have a question. Can any of you whistle like this? Anyone have a loud whistle? So I walk down the hall. And no one can whistle real loud? If we had two people in here who could whistle really loud, so someone like this, something like that, if we had two people who could do that, in your ears, you would literally hear, you would hear it high pitched, but every now and then you go, and there's something called destructive interference that's taken place. Destructive interference is basically where you had a max on one. If you had an exact max on one and an exact min on the other, and these are the exact same distance, these cancel each other out. Okay? And when they cancel each other out, that's what you'd be hearing with the sound waves, which is kind of cool. So if you ever come across two people who can whistle really loudly, have them whistle at the same time really loud, and you will hear in your ears, you'll hear the two whistling, but at certain increments in it is when one is at a maximum and one of it is at a minimum, and they destruct each other and they cancel each other out. So the woo is it destructing out immediately. You're hearing it fast. And that's basically how things go on music. How you can tell things aren't good to hear is you can hear wrong notes because it doesn't follow the smoothness of what the melody of the song is doing. So that's just kind of a little real life application of this kind of stuff. I mean, we're on a very simplistic level of it. All right, number 7, we have 2x minus 3, and we have 2x plus 3. So what are these operations doing with each other? Well, there is some cancellation. Why? Okay. So how would I do this problem? So it's like a double distribute, agreed? So I'm going to distribute this here and here, and then I'm going to distribute this here and here. Now, if you went through and you double distributed the whole thing, 2x times 2x is 4x squared. 2x times 3 is positive 6x. Negative 3 times 2x is negative 6x. And negative 3 times positive 3 is negative 9. This right here is your destructive interference. So you wind up with this as an answer. Okay, if they didn't cancel out, you just add up the like terms. We doing okay, friends? All right, let's take a look at problem number 9. Yeah, baby. Okay. So is this another double distribute type of problem? Yeah. So x is going to get distributed here and here, and positive 5 gets distributed here and here. So x times 3x is 3x squared. X times negative 4 is negative 4x. 5 times 3x is 15x. 5 times negative 4 is negative 20. Do I have like terms in there? Those are like terms, so combine those together. It looks like that. Okay. So, how do you feel? So what I'd like you to do between the rest of this class and tomorrow is do problems 2 through 10 even. I will mark that off, go over it. That'll count as a homework. So make sure you keep the sheet when you bring it back tomorrow. I will double check that you tried those 5 problems. Now you have plenty of time right now to probably get them done. Get them done, that means you don't really have too much for you. Tomorrow when we come to class, we'll go over those 5 problems and we'll also do the backside. But this will be the first 2 days of our reviewing for your final, okay? And the final is something that if you hold on to these sheets and you just, at a minimum, looked at these sheets and kind of went over them a little bit, you would probably do quite well on the final, okay? The final is worth a certain portion of your grade, okay? So usually the final exam can take care of this situation a few different ways. So think about this. Let's just pick the person who has the 78% and the person that has an 82%. Okay? The final, if you've done well enough on it, can improve the 78% C to a B. And it might be a B or a B minus, but B is a B. The final can also ruin somebody who's at the borderline. Okay, if someone comes in and they get a low F on the final, and I'm talking real low F, like 7%, 8%, 10%, which none of you should get unless you try to get that. That could take the 82% B to a C. Okay? So if you're sitting at like a 97%, it doesn't really matter how good or bad on the final you get. You're pretty much stuck with getting an A. Okay? If you're middle of the grade, 85%, 86%, or 75, 76, or 65, 66, the final's not really going to have a huge impact on, it's going to change your percentage, but it's not going to change your letter grade. Okay, so you just want to be cautious. The final will all be multiple choice, so all of the answers are there, including the one kid who comes up, hey, none of the answers are here. Well, you did it wrong. Where did I go wrong? Somewhere in the problem. So that's what's coming up for you in a couple of weeks, right? So you know what to work on?